So I'd like to also begin by acknowledging the Wurundjeri people. So I'm on their traditional lands here in Melbourne. I'd like to pay my respects to their elders past, present and emerging, and all Aboriginal people that might be on the call today or might be seeing this later on YouTube. So this is an interesting sort of connection I find between the kind of work that I started doing in my PhD, which was essentially looking at twin studies. And back then, I was coming from sort of business and different areas of sort of innovation management. And we thought it was a good idea to establish a twin registry in Brazil to conduct scientific studies. The focus was essentially on musculoskeletal conditions and so on. I had no idea or no knowledge about twin studies and why I studied twins. So a lot of my PhD was actually spent on trying to understand the sort of nature and nurture debate and how twin studies, sibling studies, and so on can contribute to the understanding of health outcomes. A few years ago, probably around 4 years ago, I met Stuart and many others in the team and started sort of maybe we'll call it transition in terms of careers and working now primarily on justice health. And the idea of this talk is sort of to merge the two things in a way that hopefully you'll hopefully make sense of it, and hopefully we'll have a fruitful discussion. So the idea of this talk sort of came for those who are on the WhatsApp group, and I recommend for those who are not, is a really interesting way to connect with others that we have in the Justice Health group. That it came from a sort of Friday night rant on sort of my frustrations I find with sort of this kind of the way the nature and nurture debate sort of plays on. And I wrote the title first and then designed the talk later. So the title is a bit confusing, so hopefully it'll make sense. It will all make sense to you as we go. So I'll start by, and just a disclaimer here, is the first time I give this talk, so I was putting the slides over the week, so it's the first time. I had no time to practice this, but I'll start by showing Charles Darwin. I mean, many of you will have heard of Charles Darwin with his theory of evolution, made some really important contributions to science, but not a lot of people know his cousin, Francis Galton. And it looks like their work is very interconnected. So now I'll explain why I'm starting with this sort of historical approach, because I think it helps us, or it helps me anyway, understand the way this field is in now, because it all starts with some sort of motives and intention and so on. And this is coming from an article in The Conversation saying that Francis Galton pioneered scientific advances in many fields. And this is such an interesting character that once you start looking at his contributions, is kind of all over the shop. So he was the first to describe the weather on a continental scale. So he came up with tools in terms of how to measure weather and how to produce statistical reports on weather. And then he went on to develop his ideas in terms of statistics. So he was, I think, obsessed with the statistics, and he ended up discovering or designing the concept of standard deviation, or looking at variation, which we use in pretty much everything we do in epidemiology and statistics these days. He invented the field of psychometrics, which is kind of like, again, just navigating across different disciplines. So psychometrics is essentially the science that measure psych outcomes. So it's measuring mental health scales and so on. So he was sort of the first one that was doing that for scientific purposes. But perhaps what's relevant to us today, and that's probably what's he's most famous for, is he essentially created this sort of scientific paradigm of twin studies and looking at twin studies in a way to have genetically informative designs. And by his own words, he was inspired by Darwin's theory of evolution, where he wrote the history of twins as a criterion of the relative powers of nature and nurture. That was in 1875, so that was 150 years ago. And so this is how the nature and nurture debate began, because there was no discussion about nature and nurture in that way. So he sort of coined that idea. Obviously, he didn't invent nature and nurture, but he was the first one to sort of start to make sense of it in a sort of statistical sense. And then why is that the case then? Why twins can inform us? And this is a very busy figure there, and I don't really want to go through everything there, but this is essentially a visual representation of the genetic differences between dizygotic twins, who are the what we call fraternal twins. So they're like any pair of siblings, except for the fact that they were born on the same day. But in terms of the fertilization processes, there's two eggs are fertilized. They share around 50% of their genes, and they end up pretty different, as we probably know. My dad is a zygotic twin, and his twin brother is now very different to him after, I don't know, 70 plus years. And then monozygotic twins are a different case because they come from one egg that's fertilized and then it splits. And depending on when that splitting process happens, they will end up with different circumstances in terms of placenta, in terms of chorion, but all monozygotic twins are also called identical, so they share 100% of their genes. And the other side of the debate and it's nurture, right? So nurture, for the concept that we're trying to discuss today, is essentially what's environmental, what comes from the shared environment and the individual environment. And here, a couple of pictures of twins. So these are the couple of twins when they were young, very similar. And then as they grow up, obviously they start having individual experiences and individual exposures, and they start becoming different, obviously. So this is essentially the two sides of the coin. And again, bringing some historical perspectives here, you might have heard of Gregor Mendel. So we now have Mendelian randomization and Mendelian traits. And Mendel was working in biological sciences, but focused on plants. And he sort of came up with this theory of how traits are inherited. And that was later applied to human research. But essentially that idea that we have that, so he didn't study twins specifically, but now we know that twins, identical twins share 100% of the genes, siblings share around 50%. And then when you go to cousins and half siblings, it's 25% and so on. So it's that sort of one divided by two ratio. And Ronald Fisher is the other important figure here that used the concepts from Galton and Mendel to sort of create statistics that you could kind of make sense of those distinctions between nature and nurture. And so this sort of like is the sort of background of the classical twin design, and we still see a lot of those studies being published today, and I'll come to that. So the idea is that you disentangle, you separate what's genetic from environmental. But then here it's important that we're talking about variants, right? So it's not really causes of a trait or causes of a condition. It's just an explanation of why people are different for that trait. And for that, and that we call population variance. In the case of twin studies, and there's a lot of studies with 200 individuals, 300, that's simply a sample measure. So it's really not that that's sort of important as some people make it to be. But the question is, how more alike are monozygotic twins or identical twins compared to dizygotic or fraternal twins, if at all? So the idea here is, again, to separate A, which is genes, unmeasured. So it's like, I'll show you with the scheme and I'll explain that to you. I hope I don't lose many people by showing this complicated figure. That the thing here is actually a lot simpler than it looks. And that's probably part of the problem with that kind of design. So we have those three sort of components, right? It's the genes, so we call it heritability, the shared environment. So it's the environment that twins and siblings share as they grow up, and then the individual factors. So things that are different for that twin sort of education. One might drop out, the other might continue, for example. So there's those differences. And this is, as any model, based on assumptions. So it's really kind of like most things here are measured. So let's say we're looking at intelligence. So you measure intelligence for a bunch of twin pairs. You assume that they are correlated in their shared environment. So both monozygotic identical twins and non-identical, there's an assumption here in this model. They experience the shared environment to the same degree. But they go to the same school typically, have around typically same friends, they have the same parents, same nutrition, and so on. And that's an assumption. And here are the assumptions about the genetics of it. So it's pretty simple. As I explained, identical twins, monozygotic sharing 100% of their genes, and fraternal sharing 50% as any other siblings. And then this very complicated thing is just to sort of give you a figure on what the heritability, how much heritability is explaining that trait. So how much that trait is, that individual differences in that trait is explained by genes. And it looks like people are very fascinated by that, and for good and bad reasons. But I'm just showing here an example of that. So you see these kind of studies published everywhere. This is on one that's on intelligence, and I'll get to the justice examples in a bit. I just highlighted here what you end up with when you're reading the abstract, which is kind of the thing most people read. Most people don't really, go and see and look, read the whole paper. But the message is very simple. So heritability in childhood is 34%, and here are some different kinds of measures of intelligence, and then increasing to 65%, 51%, and 72% in early adolescence. So it's really complicated because, like, the message here, people read that and think, well, intelligence is inherited. So if you're saying 72% for one of those measures, it's inherited, people think, well, then why should we do anything about it if intelligence is inherited? And that's not really what the study is saying. But unfortunately, there's this practice of simplifying it to a degree that the media and the public kind of read that and interpret that things are just deterministic. So, if the parents have a certain level of intelligence, the kid will be the same, and so on. And I'll show here why that's not the case and why that's problematic. Any model we call design, there's so many assumptions. I'm not going to go through too much detail on that. That's where it gets very convoluted. But the assumptions here are represented in what I just discussed. So the correlation being 100% for what we call equal environment assumption, that kind of like 1 divided by 2 ratio. That's how the sort of generic similarity goes in families when you go from identical twins to siblings and cousins and so on, half siblings. The no interaction assumption, which is like genes and environment don't interact, which we know that's not the case already. We know that it's much more complicated than that. We know that our genes and our environment, they sort of work together. They just interact biologically and socially the whole time. And it assumes that twins are representative of population. So it's like, not saying they're not, they're people like any other people, but when we're looking at some specific traits, they might be a bit different to the general population because they experience that sort of closeness that not all of us have the same exposure. And this is just to explain that really we're talking about a model that there's many assumptions there. So we can't take that finding as at face value. And I'll show you why. So when you conduct this, like this is, I'm just bringing evidence about other papers that show that those assumptions do not hold. So equal environment assumptions may not hold. Has the equal environment assumption been tested? So it's not even tested in most of the cases. Twins being monozygotic or identical, twins not being really identical because of epigenetic differences. Not really going to go into detail, but I'm just showing you that this is far from a settled debate. And unfortunately, when people publish these studies, it becomes very deterministic, and it's a really unhelpful message that's out there. And here's an example. So when you look at heritability and you look at heritability for children of IQ, intelligence, I don't really like the concept of IQ, but that's how like a lot of this field is based on. It's very different when you look at more impoverished families compared to richer families. And that makes total sense, right? Like the explanation here, and then I'm just highlighted the fact that the model suggests that in impoverished families, that 60% is explained by the shared environment, and the genes contribution is close to 0, and in affluent families is the reverse. So it's almost like what's going on here, but it does make sense. So if you say in a country like Australia or in a country like the Netherlands, that the levels in the society in terms of access to education and access to socioeconomic sort of support in many ways is very stable. Obviously, there's a lot of differences in there, but that's much different to when you compare to countries like Brazil, some countries in developing nations that have a lot more variance. So it's like there's very rich and educated people, and there are people who like, you know, can't write, don't have access to education. And that's sort of when genetics play a role. So genetics play a role when there's not much difference around, and when there's a lot of difference around in a population, genetics is really not that important. But that message, obviously, it doesn't get across as much, because people kind of love the idea of that heritability is 78%. There's such a simple message in that. But what I'm trying to show here is that it's a lot more complicated. So this is another study that found essentially the same thing. Once you look at more advantaged environments, the importance of genes is not very high, if almost not important at all. So in terms of public health, and this is what we all sort of concerned with, public health is really about equity, health equity primarily. And it's so important to kind of look at the fact that genes don't really, they're less important than the shared environment for those parts of our society that don't have access to education and systems in the same way that the more advantaged part does. And to me, that's like a much more important fact than the heritability being 78% or 60%, which is just a number that makes very little sense. And now I'm getting to criminology in terms of that criminology journal, or Justice Health. And this paper is really interesting, pulling back the curtain on heritability studies by social criminology in the post-genomic era. Is a very complicated title. But what it's saying here is that, first thing, over the past 5 years, there's a lot of heritability studies coming in criminology, which is, didn't see that. I think this paper is 2019, so I apologize, I didn't include the date here. But this is still ongoing, right? So you still have those studies looking at heritability of criminal behavior or heritability of sort of justice involvement. I'll come to those in a bit. Findings seem implausible. The models on which these estimates are based have fatal flaws for complex social behaviors such as crime. And the idea that you're trying to separate the effects of nature and nurture, say genes and the environment, is misguided because of the bidirectional interactional relationship between genes, cells, organisms, and environment. So what he's saying here is that it just makes no sense to separate genes from the environment in that way that I showed before. So because things are a lot more complicated than that model is trying to assume. So it is really like a complex relationship in terms of the genetic vulnerabilities that people might have and how that plays a role in their lives. And this is the table that shows how the literature in this area in terms of heritability studies of justice involvement, it's really flawed in the sense that there's no mention, not even a mention of the main assumption of the model. They just ignore it. They just assume it's there and it's tested, it's fine. And also not even a mention of gene-environment interaction. So I just showed that is the case, that it's really important, right? Socioeconomic status is really important for these sort of associations, but the studies don't even mention, and of course they're not even testing. If they're not even mentioning, they're not testing these assumptions. So I really don't have a lot of confidence in the literature on heritability of in justice studies, but still you see a fairly recent study like that. And some of you might know Kenneth Candler. He's just such a big name in psychiatry, made a career, a lot of out of twin studies as well. And even a very experienced researcher like him would conduct a study that says they sought to clarify the etiological contribution of genetic and environmental factors to total criminal behavior. That's flawed just from the get-go, because these designs do not look at etiology, do not look at causality. And this is one of the big problems I'm trying to come across here. It's essentially looking at differences in the population. So it's not really looking at what causes what. Do genes cause criminal behavior or not? So these studies they cannot do that. But then in the results, they say for all criminal convictions, heritability was estimated at around 45%. It's just like so simple, right? It's 45%. And obviously people read that and think, wow, it's very high. So should we do anything about justice involved people if they're sort of already on that track to just, criminal behavior continue and so on? That's kind of the message that, people reading this paper might get. And the conclusions are even worse, in my opinion. So violent criminal behavior and property crime are substantially influenced by genetic and shared environment risk factors unique to that criminal subtype. And again, the word influenced, it's causal, right? Like influence is causal by design. But that again, that's not what the study does. And I think that's very problematic. And there's examples in the media of getting that message across and saying criminal behavior is inherited. And that's very not what the literature says. And it's very unhelpful in public health. So this is the sort of reaction I get when I read this kind of stuff. Very experienced researchers putting papers out like that. Like what's going on here? There's something weird. So I talked about the sort of those designs, and it's funny that paper was published 2015 on a design that was pretty much invented, I don't know, more than 100 years ago. So people are still using that very old design, a very old idea of separating genes and environment like that, and publishing this in the literature. But we have other ways of studying twins in a way that's more epidemiologic or more focused on public health. This is an example. You look, for example, at the onset of substance use disorder, and you want to know the association between that onset with mental illness, and typically you would try to look at a later stage in a person's life. And then what twin studies do is that you can deal with what we call confounders, right? So confounders is really other factors that are in play. I'm not going to go too much into the concept of confounding here, but it's essentially like how you can get misguided associations that are not really there, but they're due to other factors that are influencing this context of substance use disorder and mental illness. And people use that for causal inference in twin studies. And this is a good example here, as good as in like, this is a controversial one that came up in the International Journal of Epidemiology. I mean, very, very strong claim there. No causal associations between childhood family income and subsequent psychiatric disorders, substance use, and violent crime arrests. So I'll just leave you with that for a minute, and I'll discuss what the paper is doing. But that is a very strong claim, saying, so childhood family income is not associated with later life outcomes in terms of mental disorders, substance use, and crime arrests. It just doesn't make any sense, but then let's kind of dive into it. And the authors say associations between family income, subsequent psychiatric disorders, substance misuse, and so on were explained by shared familial risks and were not consistent with the causal interpretation. So when they say share familial risks, they're putting everything in one box, right? Genes, shared environment. So it's everything that makes us similar to our siblings and family members. And that's fair enough. I think that's a strong a strong claim. But then that paper was very criticized, and for some good reasons and some not so good reasons. But I'm just showing here some of the responses. Are there really no causal associations? Do sibling comparisons answer the causal question? And this is a sibling study, but it kind of like it works in that similar way that the twin study does. The assumptions are similar, although they're different in the sense that there's no monozygotic twins to compare. But it's the same idea that the less genetically similar the comparisons are, you're just making the use of that ratio. So it's the same. The assumptions are the same pretty much. And I'll show you a little bit more on that. So what the criticism was about. So first thing, how representative are discordant pairs? So I'm talking about a couple of twins. So a twin pair or a couple of siblings. Just think about your siblings if you have siblings, or other siblings you might know. And then you know that they can be very different, right? So my sister and I were extremely different people, even though we were born 3 years apart. Completely different. Obviously, there's gender and there's all these influences, but yeah, we have very different personalities and so on. And when you start looking at twins who are identical, so as an example, or siblings, they're like, you're looking at people that are more similar than people in the general population. If you just get 2 people there, they're not going to be genetically similar as we are to our family members. So when the twin and sibling studies, they focus on the pairs who are different. They don't focus on the pairs who are similar, because that gives no information to those designs. So in twin studies is a problem, because how representative are they? So if there's a couple of siblings and one ends up with a violent crime arrest, for example, and the other didn't, and then obviously you're comparing to people from the same family, but what else is going on in that person's life that led to a violent crime arrest that you're not capturing in your study? So it's a really important thing, because that's kind of other factors might be in play, and other triggers or other situations might be in place for what happened to that individual for them to actually experience an arrest. So that's the problem of what we call unmeasured individual confounding. So these studies don't deal with that. So they're not really asking for each person, what else happened with your life? Did something happen? Or how did you respond to a parent's divorce or something like that? It's essentially just that sibling comparison. That's not at all helpful for arriving at such conclusion of no causal association. But the main problem here is what we call the mediation problem. And I'll try to show you an example of that. So this is what the authors of the paper did, right? So they're looking at childhood income in violent crime arrests, the association. There's some temporality there, so childhood income comes first, obviously, and they're measuring the crime arrests later in the person's life. And they just adjusted, right, for all this stuff. So on top of the shared factors that people who grow up in family share, like genes and you know, other factors that, you know, location of birth and location where they live and so on. They adjusted for all this stuff here. And it's kind of like, it would take ages for me to read all of that. But just notice that there's immigrant background, there's substance misuse, there's parental educational attainment. There's pretty much all these important factors that are very related to a crime arrest and related to child income. And in epidemiology, it's common that we have been taught to just adjust for everything. You just adjust for it, and that's how you deal with the complexity. But that's not essentially how real life works. And especially when we're looking at childhood income and justice related factors, a lot of these are actually mediated. So they're the mechanisms through which that association happens. And I'll show you an example of how the authors could have dealt with that. So yeah, there's some confounders as they included themselves: sex, birth year, birth order. That's kind of classical confounding variables. But all of these other variables, you could also claim that they're mediators. So childhood income leads to, for example, violent crime arrests through level of parental education. Though I'm not saying that's like through only that, but when you start adding all these factors in, that's how you might end up with a different outcome for a twin or a sibling compared to the other one. So all these factors, once you start putting all this stuff in the model, you're essentially removing all the causes that they're actually the mechanisms of how childhood income might lead to later in life to justice-related outcomes. And I'll show you a little bit more about this problem. And this is a paper we did recently. And again, this is a really complicated area to research. And what we did here is looking at the association between mental disorders and discrimination. And this was essentially cross-sectional analysis. So you could look at it the other way around as well. So in our study, we actually measured mental disorders first and experience of discrimination after that measure. But we can see that that's not, that we can see that discrimination might have happened before that. It's a very complex relationship. I don't really expect you to make a lot of sense of this graph, but what we're showing here is essentially exactly what that previous study showed. So when you look at the twin pair differences, they're actually not that much when you separate what is like the shared stuff in the family and the individual sort of experiences. So what is saying here, another way of looking at this is that we looked at the pairs who were both experience discrimination, and they're more likely to be the pairs where both have mental disorders. So there's not really a change in mental disorder there or a change in discrimination that might lead to a different outcome. It is the what we call unmeasured confounding taking place. So all these things like parental education, socioeconomic factors, and they are the ones who are actually influencing that relationship. And a lot of the times it is through mediation. It is through what happens in the person's life, opportunities that might be related to parental education, might be related to whether the parents have been incarcerated or not. So the study is, the difference, I think, between our study and theirs is that we made no causal inferences on that. That's essentially a descriptive study that shows, once you consider all these important factors, yeah, the association is not there. So the factors themselves are what's important, especially socioeconomic factors. But also, I'm not really discounting the importance of genes here. What I'm saying is that genes and the environment, they just interact between them in ways that our studies cannot capture. Because even if you use statistical methods to do that, we're not really capturing the complexity of those interactions at all. So coming to the paper that kind of led to my rant on WhatsApp on that day, and again, nothing wrong with the authors here at all. And again, this is an area that we published before as well. I'm just more concerned with the interpretations and the message that comes across. So I'll start with what you read first, right? So you open the paper, you read the abstract, and this is essentially the main thing they found. The associations between parental incarceration and poor health outcomes appear to be at least partially explained by genetic influences. And by poor health outcomes here, that includes criminal convictions. And I'll show there's lots of outcomes the authors looked at, including justice related. So they followed on and said the parental imprisonment per se does not necessarily increase the risk of those outcomes, but rather may reflect that the fact that families with parental imprisonment are a particularly selected group with pre-existing environmental and genetic vulnerabilities. I think that's a way more reasonable way to sum up their findings than the previous sentence. And just notice here that they now talk about environmental and genetic vulnerabilities together. And again, I'll show you why the singling out genetic influences here makes no sense. And this is one of the reasons why. So this is, again, big table. I didn't have the time to kind of digest that and just put the very important finding. But what we need to look at here, so the way they come to those conclusions is essentially they compare a model here that's looking at twins and siblings as normal people, as in like they're just correlated, but we're not looking at with impaired differences. We're just looking at the association between exposure and outcome. And there is an association here, right? Parental criminal convictions, any conviction. And same with maternal. So there is an association. We can't deny that. There is an association between parents being in prison at some point and children having higher risk of being in prison. But that's one thing that we probably all know, that there's a high risk. That doesn't mean they will experience the outcome. But when we look at the within family models, the fact that they attenuate, that the associations become smaller, is the evidence the authors use to say, well, you know what? So this is due to the familial factors. And because they also made the distinction between half siblings and full siblings, so you're essentially adjusting for more stuff. So adjusting for more genes, more environment, and so on. And obviously, it is expected that it will attenuate. It's not like, big deal, I don't think. And the thing here is that the first thing I noticed here is that maternal incarcerations that did not occur. So statistically, there's no difference between those two things here. So it's a bit of a weird thing. That's happening with parental criminal convictions, but not happening with maternal criminal convictions. And against the evidence here that you can separate genes are really based on that comparison here. And really, that is a problem because statistically, you're looking at completely different things. You're looking at people who don't have a family history. You're treating they as just individuals who don't have a family history. And then when you look at the family models, you're looking at people who have a family history. So you're comparing siblings where both have that family history of parental incarceration. So you're talking about different populations. So makes no sense to make those comparisons between those two models, especially to make a claim that genetic influences are playing a role here. And again, the scientific problem that I think it's behind a lot of the what we're seeing today and the lack of public trust in science and so on. A lot of it is because studies keep coming out with untested assumptions. People don't really describe the assumptions. Again, this study that I just showed, it assumes that genes and environment don't interact, which is just like, it's bollocks. I mean, we all know it does. You don't have to be an expert in statistics to know that it does. We all seen examples of that. And again, that the discordant pairs of siblings or twins, the different pairs are representative of the population, but you could also claim the opposite. you could claim that there's something there happening in that pair that one experienced incarceration and the other didn't, when both had their parents being incarcerated. And it could also be a fact that how people experience those exposures to, say, if the parents have lower level of education, like the siblings could respond to that differently. That doesn't mean that there's no causal association between those things. It's very different. And I included a couple of sources here, and I think the main message I'm trying to send here is that the authors cannot make those claims based on the study they conducted, and that's problematic per se. But I think the important thing in this talk is why bother with all these statistics, and why bother going and trying to nitpick what's wrong about these papers, what's wrong about the messaging of these papers. So I'll show you an example why this is important. So this is a paper published fairly recent, 10 years ago, not that recently. You might have heard about Robert Plumbing. He's like a big name in psychiatry and genetics and so on. He published a lot. And he wrote a paper called Genetics and Intelligence Differences, 5 Special Findings. Of course, the first finding that he thinks the most important thing that the genetics in psychiatry produced is that heritability of intelligence increases from 20% in infancy to perhaps 80% in later adulthood. So that's like essentially saying intelligence is inherited, like there's nothing to do about it. That's the message I get from this sort of interpretation. And again, just highlighting that this is coming from those same studies that I'll describe in the beginning of the talk. So all these flaws in design, in statistics, and so on, the interpretations, they're still coming out. People are still publishing this stuff. And of course, that's controversial. So Robert Plumbing, about 5 years ago, published this book called Blueprint, How DNA Makes Us Who We Are. I mean, they're so deterministic just on the cover. And there was this article here. Sorry, I couldn't put the name of the author. I forgot about that. But you could find that on, if you Google that. So Blueprint by Robert Plumbing, latest intelligence genetics book, could be a gift to far right. And you could see how, because he claims that DNA is the major systemic force, the blueprint that makes us who we are. Implications for our lives, for parenting, education, society are enormous. This is from his, I think, previous version of his book, but that's the Blueprint book. That's coming from the guy who said in 94, the bell curve for whites is centered roughly around like 100. The bell curve for American blacks, roughly around 85. Heritability estimates range from 0.4 to 0.8, indicating genetics play a bigger role than environment in creating IQ differences. Again, based on flawed evidence, right? So you can see that it's a continuation of someone's idea of life that's more portrayed rather than the actual studies they conducted. You remember I mentioned Ronald Fisher is a big name in statistics. There's buildings after his name in the UK. Is also sort of being cancelled now because of his eugenic advocacy. And this was in the 50s, 60s, and 70s. And the claim here is that, well, contributions to science aside, we have to kind of understand the motives. And, you know, like, it's kind of like, I don't think we can separate the scientists from the science. And that's kind of the message here. And it raises a flag when the people who designed those methods were involved in very questionable practices, like the eugenic movement. I mean, we all know how that's not based in science and how counterproductive that has been for public health. And obviously that's kind of apparently making a bit of a comeback, unfortunately, these days. And you might remember that I started the talk with Francis Galton, right? The genius that, cousin of Charles Darwin, that so many scientific advances, but you're probably not surprised that he also founded the racist pseudoscience of eugenics. So this is from 1904. So this is how it all started, right? So eugenics is the science dealing with influences that improve and develop the inborn qualities of a race. The aim is to represent each class or sect by its best specimens. It must be introduced into the national conscience, like a new religion. So now you kind of look back and you think, well, why are people still publishing those designs and this kind of evidence? Why does it still make so much noise? If looking back, not only the statistics of that flawed, but also the motives by inventing those designs were based on preconceived ideas of the people who developed them. And I think this is so important to understand, because I, again, don't think you can separate the scientists from the science. I'll leave you with some key points. All models are wrong. Some are useful, and I showed you a few that are not useful. Hope you take that as a takeaway. Model assumptions are an oversimplistic way to attempt to see a world that does not exist. This is really important. So it's the world that was displayed in those studies is a world where genetics is in a box and the environment is in another box, and they don't talk to each other. We now know by science as well that that's not the case. Models are created with intent. All scientists have their biases and personal views. That's something we all have to come to terms with. And I would like to share this last message that we have to beware of the jump between the scientific facts and a person's interpretation, and misuse and oversimplification of the scientific method that people like to use to sort of win an argument. So if it's based on the scientific method, it means it's correct, it means it's a fact. And we know it's not the case. And that's a problem for researchers, the media, the public, but also especially for policymakers who are making public health policies that impact the lives of everyone, especially more vulnerable populations. I wasn't making this up. This is all based on published evidence. Of course, it's a bit of my own interpretation here. I'm not going to deny that. But if you're interested in the stats about some of what I talked about, these are some good sources. Yeah, thanks for your time. And I'll stop sharing now.
Well, thanks very much, Lucas. That was amazing. And I feel like you did an incredible job of explaining some very complex methodological stuff in a way that would resonate for the rest of us who don't have your background in those studies. I guess a key takeaway for me is to be very cautious about any simplistic reductionist characterizations of heritability. And I think I'm not the twin expert, but that it sounds like this assumption that we can separate out genes and shared environment is being challenged, and really we can't trust evidence that just without basis claims that they have disentangled those two things. But look, we do have some time for questions. I'm sure I'm not the only person who had some questions. I'll turn it over to anyone else.
I probably lost half of the evidence through half the talk. Hopefully not. Hi, Matt.
Hand up.
Hello, Lucas. Yeah, I just reaching back to my own PhD. I did mine on the genetic epi of melanoma. And one of the things that was just emerging at the time was the idea of epigenetics, where the environment actually, my memory is that it's when an environmental stressor modifies the function of the genome without actually causing due to a mutation. So given that the paper that you critique didn't really look at the interaction between environment and genetics, are you aware of anyone else who's looked at the effect of epigenetics in this area?
Yeah, so thanks, Matt. That's really an important point. And I think it is obviously a source of that sort of trends that we're looking at. So epigenetics, as Matt was saying, is essentially when, let's use an example here. So if, say, parental smoking, for example, might cause some differences in how the children's genes are expressed, although it doesn't change the person's DNA. So the DNA continues the same, but the way the genes are expressed might differ. And there's some studies now that, although these might explain partially the differences, or sort of like that kind of big black box in terms of genes and environment interact, they are not the big source of variation. They might be a big source of the biological interactions. But what I'm sort of more concerned here, I think, in this talk was the sort of interactions between, say, when someone has some genetic susceptibilities to mental health disorders, how that influences the environment that then influences the future environment of that person, and how other sources of exposure to socioeconomic factors might play a role as well. So at the biologic factor, surely the epigenetic factors have a role, but the evidence seems to be more on the size of conditions such as cancer, conditions such as cardiovascular diseases, and so on, when we look at diseases or conditions like mental health disorders, substance use disorders, or even social outcomes like justice, epigenetics are really not the big source of explanation to those differences. But again, there's a lot of the problem now is that a lot of the claims are being made on the best evidence we have, and that's fine because that's how science goes. But I think in terms of public health, I think it's a bit different because you can't just keep putting science out there as, oh, this is what we know now. Like the candidate genes are an example. So 10 years ago, people would find candidate genes for everything. They're candidate genes for justice involvement, and they're published out there. And now that science is being debunked. It doesn't exist anymore, but the papers are still out there. So I think there's a problem with putting messages out there that we don't know yet. It might be the epigenetic factors have a bigger role, but so far the evidence is not there yet. And I think we need to be, just mindful of that. But that's a really important point. Yeah. Thanks, Matt. Lee?
Hi, Lucas. Thank you for your talk. I work as a doctor in youth justice in New South Wales for Justice Health. So we've got a very high population of Aboriginal Torres Strait Islander young people, about 60% at the moment, unfortunately. I thought your talk was interesting. I think it's problematic for countries that have relatively homogeneous populations and high incomes to do those sorts of causal studies that don't perhaps have sort of an Indigenous population group to include in those studies. And I wondered if any of those studies or in your research you'd come across the influence of prenatal substance use exposure, in that relationship, but also having that epigenetic effect that Matthew referred to in this, and it's something that's very hard to measure as well.
Yeah, thanks, Lee. And on your first point, I do agree. And the studies that I cited, spent more time on, they typically come from Scandinavian countries, a lot of them, and a lot of it is because of the data availability. And even with data linkage, you could still end up missing a lot of the vulnerable population. And once you start incorporating a different strata of society that typically doesn't participate in those studies, you add variation to it. And we all saw from that evidence that when you introduce variation, the genes start playing a smaller role. So that sort of contributes to my thinking of why we are not seeing a lot of genetic studies with a lot of genetic variance in genetic backgrounds. First, it's very hard to do, but it sort of counters the evidence that's out there. So we all know how, scientific sort of paradigms work. And if there's data that's contradicting previous findings, people don't really know how to deal with that well. When it comes to your previous point, I think it's what's hard to separate here. I think you were talking about sort of parental substance use disorders and the outcomes in the children. So epigenetic effects have been sort of they're sort of evidence that they exist, especially when it's happening during pregnancy. And obviously that introduces a potential causal association to that baseline of their children, right? Like how their children start their life. The problem is there's a lot of confounding here because that parental substance use disorder will keep affecting their children over their lives. So it's really hard to separate the biological component, and we know that that's fetal alcohol spectrum disorders and so on. They're like a direct link. It might not even be an epigenetic one. It's just a direct link between alcohol consumption and pregnancy outcomes. But it's really hard to separate what's going on in terms of the influence of that parental incarceration, any trait that you're looking at that has social implications through the kid's life. And that's what those studies can't do it properly, because honestly, we think we're very advanced in scientific methods and data and so on. We just don't have the capacity to be that specific. And the data that we use is not specific enough. So some studies that I looked at, they're looking at sort of medical records and so on. We do a lot of data linkage studies as well. We know that helps you covering a larger portion of the population, but that you lose a bit of the nuance, you lose a bit of the individual triggers or exposures that might lead to a kid, for example, developing that substance use disorder or not. Yeah, I think it's it's such a complicated area that's why I was making that point, that you can't really go out and say this is confounded by genetics when your evidence not pointing to that, and why you're singling out a factor when you still don't have evidence on if that's really causing. So did I answer your question? I think the answer is it's so complex that I don't think we have the evidence to know yet.
Yeah, no, thank you. That's really interesting. My research, my PhD, was on the ARDEC study, antecedents of renal disease in Aboriginal children. And it was a little bit like a 7-Up study, but we followed up the kids every 2 years, and it was comparing cohorts of Aboriginal and non-Aboriginal children within the same demographic group, so within the same locations across New South Wales, to kind of control for some of those socioeconomic confounders and disadvantage. And it was interesting in that it didn't show any particular difference for health outcomes for those kids until those markers of disadvantage started to separate between the two groups. And then you'd start to see the Aboriginal children getting more early markers of heart and kidney disease and other things. So it was a little bit more convincing that it is, those social determinant type influences on health.
That's an interesting point, and I think that there's ways to sort of introduce those nuances into the studies, right? As in looking at, because the twin example, the twin study as an example, it assumes that the twins are similar, but as soon as you start measuring, and you're interested in the effect of that confounding variable on each person, right? So it's not that whether they're experiencing the same parental education, it's the effect that has on each person. So the effect of parental education can be different in the twin pair, between the twins, and it can be different between siblings as well. And I think we just don't have the nuance to sort of separate. And because of the lack of nuance, those studies come with those conclusions that, it's due to genes, because there's just unmeasured factors in play that we're just not looking at. And I think your example is great. I'd like to actually know more about the study, and I'll look into it. I might be in touch with you on that.
Certainly, thank you.
Joy, we've got a couple of minutes, please. Quick question.
Yes, so a couple of comments. Finland is known as one of the world's best places for social security and care of. So the study that looked at and whether or not economic disadvantage played a part could have been dulled and impacted by the fact that Finland looks after their population so well. They're also known for being leaders in the world in their approach to people in custody, as having a rehabilitative, trauma-informed process, which includes ensuring they have very good contact with their family, and the kids can even come and stay with the parents in special houses inside the jail. So the secondary impact on the next generation may be muted. When you look at the adverse childhood events score, the ACE scores, which I'm sure you're all very familiar with, the vast majority of those directly relate to experiences within the family, including incarceration, mental health, AOD, separation, and seeing violence. And we know that trauma affects the epigenetics. And so obviously there's huge confounders there where the genetics is directly impacted by the environment in the same family groups, and it's directly related to time in custody. And it would be interesting to have studies that looked at protective factors to protect people from in custody versus factors looking for weakness all the time. And I think Scotland's been doing some work in that area where they're identifying the families of people in incarcerations or children in daycare who are showing signs that trauma may be occurring in the household or lack of direct eye contact, etc., with the parents. And they're proactively looking at interventions early before the kid ends up as a delinquent teenager to support those vulnerable groups.
Such a good point, Joy, and I take you also your first point about how stable and similar I think the Finnish society might be compared to other countries. And obviously, when you start looking at those families that have access to healthcare, education in a much more stable way than in other countries, the very discordant siblings are probably not as representative of the population that much anymore. So there's something there that the authors did not measure in terms of understanding, for example, ACEs and the other influences that might have impacted each children differently as well. So it is such an important point, and we do need a lot of evidence from other settings to be able to kind of validate, or at least just to have evidence on other contexts as well, so we can make more informed decisions. Yeah, thank you.